everybody. Okay, we're going to be kicking off this webinar any minute now. Okay, so good afternoon. We're going to kick this webinar off in just a minute. This is our first time streaming directly to YouTube, so it's a bit of a trial for us at the moment. But yes, can everyone hear me all right and see me all right? That's the two important things. Cool. Excellent. So we're going to start this webinar and take a look at Archviz in Unreal Engine using Speckle. So this will be a great webinar for people who are new to either Unreal for Archviz or new to using Speckle in Archviz. And so we're going to look at the workflows surrounding how we can use Speckle in our Archviz projects. So we're going to walk you through the creation of a very simple Archviz project within Unreal. We're going to just take a look at installing the Speckle plugin for Unreal Engine and how we can receive and receive streams. We're going to take a look at how we can use the material overrides features of the Speckle plugin to automatically apply materials. And we're going to look at using Quixel Bridge for materials. Cool, so this webinar should be very approachable for people with no real experience in Unreal Engine and no programming experience, and so it's going to be very kind of a basic overview level of using Unreal Engine. So for the more dev-focused viewers, we're going to be doing another tutorial or webinar later, and that'll be more focused on diving deep into the code of the Unreal Speckle plugin, and yeah, that'll be later this month, maybe a couple of months, hopefully before Christmas, but we'll see. But yeah, we'll just start it off now. Cool, so we're going to be using Unreal Engine 5 for this, for no other reason than we just wanted to show kind of the up-and-coming latest version of Unreal Engine. Most likely in production we won't be using Unreal Engine 5 at the moment, but it's getting to the point where it's quite exciting, and I'd like to show you guys the cutting edge of what Unreal has to offer. So we're going to go ahead and open up Unreal Engine 5, which will take a second because it always does. And we're going to create a new project using the architecture, engineering, construction blank template. It doesn't really matter what we use for this webinar. which template we use, but this is a good start and will help us out with some of the lighting and things. So just give it a quick name. So unfortunately, I don't have access to the new 3000 series graphics cards, so we won't be able to show off the fancy ray tracing that Unreal Engine has, but we have got Lumen, which is a nice software ray tracer in Unreal Engine 5, which we can demonstrate here, although performance won't be quite optimal. But we'll just kick it off. So for those who aren't familiar with the changes Unreal Engine 5 has brought, we have a new software renderer. We have the lighting global illumination, which is packaged as Lumen, sorry, and we have our new software renderer for the meshes, which is nanites. And for those who haven't been following the Unreal Engine 5, nanites is quite interesting because it allows us to render very complex scenes with many thousands, millions of vertices without the performance degradation that we would normally see with normal hardware renderers. And so we're just going to explain quickly kind of what's in our current scene, what's in the Archviz template, just for those who aren't familiar with kind of some of the Unreal actors. So we have a camera actor in our scene. We're not actually going to use this one, we're going to delete that and recreate it, but this is just a camera that we can do movie-like renders with, so kind of fixed animation, camera paths, and output as a video render. For real-time rendering, which we're going to show off, we're going to be using a different actor, but that's fine. Our exponential height fog, that's just kind of some of the fog effects that we see in the horizon. We have this floor mesh, very straightforward and simple. We have a player start for our runtime. We can ignore that for now. We have a post-processing volume. For the minute, kind of ignore the fact that it's a volume. That's not super necessary in this case, but what this will do is apply some extra effects to our camera. So if I quickly demonstrate those, I think there's some extra bloom and exposure, so we can adjust certain parameters here. But this is kind of just making our camera look a little bit nicer. We're using some post-processing effects, and this is all customizable in a way that's a little bit abstracted from normal Unreal Engine, where you kind of are writing your own shaders that apply on top of the camera, render paths and things like that. For the Archviz workflows, we're not really interested in kind of the low-level creation of coding our own shaders and things like that. So Unreal Engine provides a lot of abstractions that we can just use out of the box, and one of the great examples of that is this sun sky actor. So if I enlarge this, so this sun sky actor has certain components to it, and we don't necessarily need to worry too much about what these components are and doing. I'll briefly just show you an overview and rundown, but it's kind of a detail that is unnecessary for most users for the Archviz workflows. So we have this compass mesh, which is just rendering in our editor. This won't appear in our renders or when we do the play of the scene. We have a skylight, which is giving us some shadows. If I... Does this cast a shadow? This doesn't cast a shadow. Okay. This will giving us kind of the sunlight. We can see here it has its own kind of... we can adjust the light color manually if we'd like. So I got that slightly wrong. So the skylight is emulating kind of the blue light that would come from the sky. That's a very subtle tint. I can turn that on and off here. So it's a very subtle tint, but it's effectively, without it, our sun is very harsh, and from a single angle we would get some very harsh shadows. And so this kind of emulates the light that we would be reflecting off the sky and through the blue sky. Our directional light is emulating the actual directional light from the sun, and these are kind of standard Unreal components. We can edit them manually here, or this is the beauty of our Sun Sky Actor is this provides us with a nice abstraction that would be very much more useful for sort of architects, engineers wanting to do real-time or movie-like renders of their scenes. And the abstraction effectively is like a sun. We can set our longitude, latitude, time of day, and that kind of thing. So it would emulate the physical-based rendering that is kind of the sun in the sky. So yeah, we're gonna leave these as defaults now because it's a nice setting. But I just wanted to explain a bit about under the hood what this Sun Sky Actor is doing to create kind of the effects we want. But as just a quick demonstration, if we say move like the day, we can see how the sun would change. We've got a nice sunset. If we'd like a sunset, we can change obviously the time and see how the sun moves in the sky. We can animate this as well, and we'll get around to that in just a minute. So yeah, that kind of explains kind of what is in this default scene and kind of how our workflow is different from a traditional Unreal project of dealing with these components directly. We're now using this Sun Sky Actor, which simplifies our workflow a lot. Cool, so the first thing we're going to be doing is installing the Speckle-Unreal plugin, which is a relatively easy process, but it's one I think is valuable including in this webinar, just as a kind of here's a step-by-step guide of how to do it. All right, so first thing we're going to do is navigate to our project folder. So if I go a few levels up from here, we have our Unreal projects, which is all of our Unreal projects. We've got our Speckle webinar project here with our U project extension here, and we're going to create a new folder just called plugins, capital P. There might be one already there created for you. If not, create it yourself. And then within here, we can go ahead and install the Speckle plugin. There's a few ways we can do that depending on your own preferences. So the method that I'm going to be using is using Git. But if you haven't got Git, the process is very similar. Effectively, you would go to our Speckle systems repository. Under Speckle-Unreal, we can download our project as a zip and then copy the contents of this zip into our plugins folder. So we would effectively just move this folder over here, but we're not going to do that because there's some advantages to using Git in that we can receive updates and we can also contribute back to the Speckle project. So I'm going to quickly show how we can do that now. Effectively, we're just going to be cloning our repos. So we're going to be copy and pasting the URL here, pasting it in. I didn't copy it right. Adding the .git extension, and then that effectively will do the same, plus tracking the Git changes, so we can easily receive changes. We are going to be looking at publishing on the Unreal Asset Store quite soon, but that's not in effect at the moment. So this is the way we would install. Yes, give me 1 second. I've made some changes to a separate branch, which I'm just going to quickly one moment. Okay. So now we have the Speckle-Unreal plugin installed. We can go ahead and restart our project. And this will prompt us to recompile. So yes, would we like to rebuild? And yes, hopefully this shouldn't have any problems. So yes, as with a lot of things on Unreal Engine, this takes a second. So. Okay, I'm a little bit. Oh no, he's doing it. Okay, got a little bit concerned there that was gonna never finish. So that process only has to happen once on installation, and yeah. So now our Speckle-Unreal plugin is installed. We have access to the Speckle-Unreal classes. So the easiest way to bring those into our scene is bringing in the Speckle-Unreal manager. I'm going to quickly demonstrate what this actor does. So we can specify our Speckle server, a stream ID and an object ID, and then we can receive kind of any object from our stream. Currently in the works is a nice UI allowing us to kind of bring in streams a little bit easier than having to copy paste the IDs, but that's not quite production ready at the moment. So at the moment, this is the way we work. We enter our Speckle server and stream IDs. So I'm going to just quickly paste in our stream that we're going to test with today, and quickly show you what that is. So yeah, so this is an example from the SketchUp 3D Warehouse by Aaron P, and we're kind of going to use this to model how a workflow would look like from SketchUp to Unreal, but this applies, the process of what we're going to do inside of Unreal applies to kind of any 3D model from any software, right? From any of our supported software. So this is the model in Speckle, and we're going to just quickly receive that in here. So we specified server ID, stream ID, and the object ID, and that's the object ID of the root object. And if this was a private stream, we would also need to specify our auth token. Because this is a public stream, we don't need to do that. The Speckle-Unreal docs kind of have a bit more information on how we can do that, but for now, because it's public, we don't need to do that. And so we can import this stream. Because this is quite a large stream with a lot of blocks, it will take a second. But once this is in, I'll show you kind of what this looks like and how this is converted into Unreal actors. So the original idea for this webinar, I wasn't going to go too far into kind of how we are doing things under the hood, but I think because we're good on time, I might quickly do a very brief overview of kind of how we're converting certain things into native Unreal actors. So once this is in, it will take a second. Okay. Yep. So here's our mesh from our data from our Speckle stream, and this is quite a good example of the new Lumen ray tracing. We can see some very nice, I'm just going to quickly slow down my camera because I'm moving a bit fast here. So very nice shading and lighting we have just out of the box. This is untweaked from the template, and we can see the performance in Unreal Engine 5 for the quality we're getting is much greater than in Unreal Engine 4. So this is one of the reasons why we're quite excited about Lumen and Nanites as well. Okay, so one of the nice features of Unreal Engine 5 also is we have Quixel integrated into by default. So for those who aren't familiar with Quixel, it's a huge library of really high quality digital assets and materials that are all provided free within use within Unreal Engine. And we can see over here we have some great examples of plants, materials, kind of 3D assets that we can use to make our 3D renders not only look amazing but also do it in a way that's quite quick and easy to do. It doesn't really require a lot of manual work that traditional kind of forms of ArchVis would, and so we can create a scene that looks rather nice and pleasing and immersive without having to kind of manually do a lot of work. And this is where Speckle, the Speckle materials workflow comes in. So within our Speckle Unreal Manager, we have this materials tab where we can specify certain materials to be used instead of the converted materials that Speckle will create. So at the moment, the current support for materials within Speckle, so like sending between different connectors, we only support a standard physical based properties based material, so no textures as of yet. That is something we're looking into supporting at some point, but at the moment this is all we support. And even if we did kind of fully support sending materials, there's reasons not to send very high quality 8K materials over to say something like Revit, which would kind of hurt Revit's performance quite significantly because it's not made for kind of realistic rendering, at least out of the box. And so the one thing we're going to be looking at, if I just expand this out slightly, is we can override how materials are applied to our actors in our scene. So we can do this in two ways, which is by the ID of the render material or by the name of the material. So I'll quickly explain what that is. If I click on, say, one of these bushes here, and I look at the kind of the way that Speckle is structuring this block, is that we have under the block definition geometry, we have our kind of meshes. So this is actually made up of a few meshes, I believe. I wonder if this will allow me to select it. It won't. That's fine. And the meshes, let's see if I can find. It's a nested block. It's a block within a block. That confuses things a bit. That's okay. So these meshes have a render material which specifies kind of the PBR properties of the material. So we've got opacity, emissiveness, metallic roughness, and diffuse. Diffuse is the kind of the base color, and it's stored as a RGB int, which might look a bit funny here, but effectively it's just a color. And so what we'll use inside of Unreal Engine is we'll use that and create a material from it. We can see that in Speckle, the stream ID materials folder, we have all of our converted materials, right? So these are all the materials we've taken the render material object and created Unreal materials from. But obviously, because that's going to lead to a flat material, it's not entirely desirable for our end result. And so one of the benefits of Unreal is we can make these really realistic looking scenes, and so we want to have our high quality materials. So what we can do is override these materials that Speckle generates within our Speckle Manager. And that's the Speckle ID here, so the ID of the material. Okay, I've lost it, but each object has an ID. Or we can do the name of the material. So what's quite common is, for example, in SketchUp, you have your materials that you've set in SketchUp, and they have a name, and you want to be able to bring those same materials into Unreal and just automatically have them be applied, right? And that's just a case of adding them to this array of materials, right? For the demonstration we're going to do today, we're going to be overriding by ID, which has an extra kind of step to it, perhaps, but we're going to quickly demonstrate what that is, and we're also looking for some sort of feedback as well in terms of kind of how you're wanting to use Speckle-Unreal for materials, and which kind of ways we can make this this process slightly better. So one of the active issues we have on our GitHub board is for improving this materials workflow, and we've kind of created some ideas of how we can do that, and we would love a discussion kind of either on GitHub or on our community forums about kind of making this process a bit better. But for now, I can show you what we do support and how we can work with this. So for example, if I just quickly come out of this and I open up Quixel, we can search for some materials. So in this scene, we have a plastic chair, and I'm going to be looking for some sort of plastic, if I can spell it right, material, right? So if I go into surfaces, we have some materials. So this one here, scratch polyvinyl carbonate plastic. We can download that quickly and then add that into our scene. One of the interesting observations that a lot of people make about Quixel's library is there's a lot of distressed materials, a lot of kind of worn concrete and worn materials, and I think the biggest kind of shift in mentality we have to have when creating realistic scenes is we actually do want imperfections, and we do want not necessarily distressed materials, but materials with imperfections, right? So when people look at this material name and say, oh, it's scratched, I don't want my chairs looking scratched in my render. Well, actually, if they weren't, slightly scratched, they'd be looking kind of unrealistic and too perfect, right? Which often is undesirable. Photorealism is our goal, and particularly when we come to doing the glass, you'll see that actually we're using kind of imperfection masks and things like that. So if I just drag and drop this onto our mesh, this will apply to our mesh. However, what it won't allow us to do is receive our stream from Speckle, because the minute we do, we're going to notice that this mesh is different from what is on Speckle, and we're going to be taking the Speckle changes. So the way that we tell our manager not to kind of override these is by specifying it as a material override. So we're going to just quickly create a new material here, drag our kind of textured material in, and we're going to go over to the converted materials tab and find this texture, which is, I believe, it's called something rather nondescript, like material 17, is that correct? So we're looking for color AO3, right? So if you want to cut materials named slightly nicer, you'd be able to kind of override by name a lot easier. And then for this, we're just going to be overriding by ID. So can I find this? It's not that one. Here we are. AO3 looks kind of pink in the preview, which isn't desirable. So then we just specify that as our ID here, and then when we receive the stream, we can see that that material will then be applied to all of our chairs, and this will take a second to re-receive. Cool. And so yeah, all of our red chairs are now nice and red, right? And what we can do as well is, like, we were quite lucky that the fact that Quixel had a red material here. For something like these yellow chairs, it's quite simple just to kind of create a new material instance of this material. So it will look exactly the same. We'll just call this yellow plastic. And we can just quickly change this so it is actually yellow rather than being red. So if we go override the albedo color, we can okay, this has changed since Unreal Engine 4. What I want to do is change the this color so it is yellow. I don't think I changed the texture map. I think I change that's not quite right. Okay, I think that's not quite right either. This is, I should have prepared this. Okay, give me 1 second just to figure out why this has changed since Unreal Engine 4, which makes this quite easy. But another thing we can just do is change this material directly, I believe. No, okay, this is different, and I don't want to spend too much time making this look far more difficult than it is. Okay, so we're going to quickly just change over to, say, texturing this block here, which we can go back to Quixel with. We're going to find some sort of like marble or granite work surface sort of material. Something like this. And the idea is this kind of process is very quick to do, and you can not spend a whole lot of time tweaking materials and manually applying them and hoping that they look kind of nice at the end of it. So this gives us quite a nice result just out of the box, really. Okay, so the next thing we're going to go onto is creating some camera animations, I believe. Okay, so in our previous demo of this sort, I kind of demonstrated some more complete texturing of our scene, and that video is on YouTube as our conference talk that I did a couple months ago. So if you're more interested in kind of creating material applied scenes, we can cover that in we've already covered that in that video effectively. But in this video I want to kind of speed through and just give you a very overview of kind of here's how you do things, rather than kind of show you the amazing thing that you could do, because I am not necessarily the best of artists within Unreal. I'm a software developer, so that's where my skills are. Cool. So with this camera, I'm going to quickly just delete the built-in camera that Unreal had in their template, and we're going to create a new camera. Drag that into our scene, and we're going to have this we're going to do a camera path of this animation moving in through this doorway, and the best way of doing that is with keyframes. So if we go open the sequencer here, and we can create a new sequence. I know what it is. We need to use the other cover camera. We'd be using the Cine camera. Here we are. So effectively, Cine camera is the same as the default camera, except for it allows us to do. It's more built for kind of the movie-based rendering rather than a traditional game engine style of rendering. So in our movie render queue note, we want to create a sequence. And I have forgotten how to create a sequence. Give me 1 minute. Of course, I was just doing the wrong thing. Under cinematics animation, we create a level sequence here, and we're going to call this just camera 1 sequence. Okay, we can start editing this. We can add our camera actor, so Cine camera actor 2. Here we are. We added that to our sequence, and what we can start doing now is, if I kind of position this how I want to position this for our first keyframe, then we can start tweaking some certain properties about this camera. So by default, the Cine cameras have a very low lens field of view. And so we can just increase that up to we can increase that to a 24mm lens, say. And then what we want to start doing is creating a keyframe. So we're going to create a keyframe for the transform at time frame 0. And what we can do is skip along to, say, a second in. I think that's 2 seconds in, sorry. And reposition our camera. Kind of here. And we're going to apply a slightly different rotation to it as well. So I realise I'm doing this in a tiny little window. You probably won't be able to see very clearly. And if I add another keyframe in here for our transform, then we should see that we are animating between the two now here. Okay, so we're a bit close to this wall here, which I don't particularly like. And so what we're going to do is add another keyframe kind of here. We're just going to skew this out a bit. Add another transform keyframe here. So now we are kind of avoiding this corner slightly more, which is quite nice. We can also keyframe certain things like the focal length. So if I mess around with the focal length, not the focal length, sorry. Okay, I don't know enough about cameras to be able to do some nice bokeh effects. But effectively, the Cine camera acts like a regular camera. The normal camera kind of is an abstraction of a camera and allow you to edit the camera in a way that's not mimicking kind of real life focal lengths and apertures and things like that. It'd be very simple, like pixel based FOVs and things like that. So this is more similar to Blender or traditional rendering engines, 3ds Max kind of thing, which presumably is a familiar workflow for people in ArchVis. So the next we're going to do a quick keyframe sort of here, and then we're going to bring this out around here, add some rotation to it so that we're kind of animating a rotation. How can I make this look good? Okay, and then another thing I can do, actually I'll quickly show you this, is I've been doing a very sort of manual kind of way of positioning this camera, but what we can do, and what's slightly easier, is if we just pilot this camera, what we can do is move the camera around like we were the editor camera, and position this exactly how we want, right? So no, this is doing a weird thing. I think I might be dragging the transform as I'm doing it. Yes, I am. Okay. Cool. So then we can set another keyframe sort of here. This might be a very fast transition. It is. Okay. So what we can do is actually a cut here. So if I change to the graph visualization mode and select these points, I believe. I need to select from here, that's why. Okay, so I haven't got enough screen space to probably demonstrate this, but so instead of this being a kind of a interpolated animation, we can create this as a different type of curve. Probably the easiest way is to just no. This has changed slightly for it's because I got a tiny window. So if we make this a constant interpolation, then what we'll see is instead of a an animation, we have a jump, although that has screwed things up. Okay, that's not the best way to create a jump. So I'm going to bodge this slightly and just move move these keyframes. Can I duplicate these? No. Okay, well, let me duplicate them. Okay, so we'll ignore that that style, but that's how you change the interpolation modes, right, and create an animated sequence like this. Now, say we want to render this. I'm going to stop piloting that actor, and I'm not going to keyframe it, so I'm not going to save that as a position. To render this as a video, then we can head over to we can use the movie renderer, or we can use the sequence recorder. I'm going to use the sequence recorder, so we can just add our we can add our sequence in. Nope, this is not how we do this. Okay, we're going to save this, add it to our scene. And then we're going to record that sequence. So, Windows, Cinematics, Sequence Recorder. Yes, camera sequence 1, that's correct. Okay, that's why it was being a bit funny, because it wasn't in our scene, it was just an asset. Okay, and then we can set, obviously, kind of the resolution that we render at, the length of the sequence, things like that. We're just going to keep this as defaults, and just hit record. No, this is the wrong thing. I realize what we're doing. I'm sorry. We do want to use a movie renderer. I'm an idiot. So the recorder is for recording your sequence if you were to do a live, real-time demonstration. The movie renderer is for rendering out our sequence. So if we do this level 1 sequence, we can render locally. Then this will give us a render of our scene effectively. So we've got a camera path in. I think I screwed up the keyframes that we did previously. But then this will output as a video. So hopefully this is kind of giving you a very basic overview level of kind of Unreal and what we can use it for. And hopefully answered some questions as to how Speckle fits into bringing your actors here. I've definitely screwed up the keyframes. That was unfortunate. Okay. Is there any questions? I would be happy to answer any questions that people have. Okay, does anyone have any questions? Feel free to message in the chat with any questions. Nope, okay, I think we're going to end this webinar now then. If there's no additional questions, don't forget to star our repos and check out our open source project. Feel free to ask any questions on the community forums, and we've got a great community of people who are happy to chat about kind of what you'd like to see from Speckle and how you're using it. So excellent, thank you very much everyone. And yes, as I said, later at some point I'll be creating a more in-depth tutorial into how we can extend the Speckle plugin, how we can do some fancy things with it, how it works under the hood, so conversion and things like that. And that might be a more engaging topic for kind of people who are interested in extending or using Speckle from a coding standpoint. I wanted to keep this webinar kind of simple and approachable for anyone, including those with no kind of programming experience. So hopefully that explains certain things. Excellent. Thank you, Ryan. Cool. Okay. I'm going to end this webinar now then. Feel free to ask some questions on the forums.